Okay. Hello, everybody. Welcome. So good to see everybody here in person in Chicago. And I know we have some people joining us online from all over the country. So thank you all so much for being here at our first teach-in Chicago. My name is Jane. I'm a graduate student at the University of Illinois, Chicago College of Pharmacy, and one of the organizers for Stand Up for Science. Okay. There we go. Today we have an absolute powerhouse of a lineup for this teach-in. You'll hear from frontline federal workers and leading scientists who help us connect the dots between what's happening in Washington and what it means for our communities here at home. We'll begin with a welcome from AFG Local 704, followed by our special guest, Deborah Shore, who's joining us online today. She's a former regional administrator for the EPA. And then we'll have two scientific talks, first from Dr. Rachel Peretsky, who is here, and Dr. Erin Pacman, before closing with a call to action about how you all can get involved. And we really hope that you leave today not only more informed, but more inspired and empowered to act in defense of Lake Michigan, our health, and our collective future. So just a little introduction. If you have not heard of Stand Up for Science before, we were founded in February 2025 by a team of graduate students led by Colette Delawala in response to political attacks on science and public health in the form of devastating cuts to federal research, as well as government censorship to a lot of different words that appear in grants and attacks on DEIA. And the first big action was to host over 30 official rallies on March 7th, as well as over 150 satellite demonstrations. And our team in Chicago had a really big demonstration in Federal Plaza, where we had speakers ranging from Senator Dick Durbin to Representative Jan Schakowsky, as well as scientists that are in this very room that are being affected by the federal cuts. We also had a National Science Foundation federal program director that was recently fired that gave a talk. Now, Stand Up for Science is a 501c4 nonprofit organization that's committed to the following policy goals of ending censorship, securing and expanding scientific funding, and defending and supporting programs that offer equal opportunity for all people to participate in science. Our local group has been steadily growing as we build partnerships in the community, where we kind of create spaces where scientists and community members can get together and learn from one another and take action. You also might be wondering what a teach-in is. The first teach-in was held at the University of Michigan on March 24th, 1965. This started right after President Johnson launched Operation Rolling Thunder, which really escalated the US involvement in Vietnam. Instead of going on strike, the faculty and students decided instead to stay in the classroom and host a teach-in, and they really turned it into a space of protest and political education. So this first teach-in lasted about 12 hours, and there were speeches, different film screenings, guest speakers, and a lot of group discussion about what can be done. And since then, teach-ins have really become a model for resistance and protest rooted in teaching. And so that brings us to why we are here today. We're here today because Lake Michigan is really life for Chicago. It provides drinking water for over 10 million people, supports our economy, hosts diverse plant animal species, and gives opportunities for swimming, fishing, and recreation. Of course, you'll hear a lot more from our experts today. All of this is currently at risk because the president's current budget proposal hopes to eliminate nearly $3 billion in annual funding that supports clean water infrastructures. Congress is also pushing to slash over $137 million from the Great Lakes program, and a lot of these funds really go to replace things like lead pipes, fix leaky systems, address forever chemicals in the water, and prevent sewage overflows. In June, EPA scientists took an extraordinary step of issuing a declaration of dissent against the administration. And since then, a lot of the scientists were placed on administrative leave, and we actually heard news yesterday that the firings have started of these scientists that spoke out against the administration. And so that's why we're here today, to confront how these federal funding cuts and political attacks are devastating our local communities and the environment. So today, let's hear directly from these federal workers and scientists that are on the front lines. And with that, I'm honored to introduce our first speaker. Michael Pasqua is a life scientist with EPA Region 5. He serves as both the Wisconsin State Program Manager, overseeing the state's drinking water program, and also as the Region 5 database coordinator for all 6 states in the region. Before joining EPA, Michael served in the U.S. Air Force as an IT administrator with assignments in Texas, Mississippi, Ohio, South Korea, and Germany. After earning degrees in environmental science and policy from Northeastern, he relocated to Chicago in 2023 to join the EPA. Michael is an active union steward with the American Federation of Government Employees, AFGE Local 704. With the earnest support of Stand Up for Science, he co-authored the EPA Declaration of Dissent, advocating for the restoration of science, equity, integrity to the core of the EPA mission, which is to protect public health and the environment. Everyone, please welcome Michael.
Thank you all for being here. Thank you to our speakers, and thank you to Stand Up for Science for hosting this. I'm Mike Pasqua, and I, first want to apologize if I come off a little distracted or sour today. It's been a difficult few months at EPA, and Labor Day is starting to feel less of like something to celebrate and something to memorialize what we've had. But under normal conditions, you wouldn't know who I am. This isn't something I normally volunteer for, and it's you just may have never known my name in the first place. But I am desperate to share the truth and what's happening to us all, and what's going to happen to us in the foreseeable future. Just to highlight some attacks on EPA since January, there have been persistent political attacks on Democrats and former President Biden. There's been attacks to our environmental justice community, diversity, equity, inclusion, LGBTQ+, women, and many, many other disinvested communities. They're shuttering offices of research and development. And after our declaration of dissent, they put our employees on over 2 months of admin leave. And as Jane mentioned, there's been firings and proposed removals of some of those signers. And they are currently lying to the press about our credibility and our intentions of that letter. They've also unilaterally canceled our union contracts. And the day we were honoring our environmental justice employees, they decided that we are no longer a union and are no longer allowed to do union activities at work or in our personal time. Lee Zeldin, the current EPA administrator, has been favoring polluters and the auto and trucking industry, and he's proposed the rescission of start-stop ignitions, pushed easy pour gas cans with branded EPA logos, and has proposed the rescission of the endangerment finding, which protects us from greenhouse gas emissions. And there are many, many more examples, and it's to be continued. This is not alarmist rhetoric. This is what's happening right now. It's happening to FEMA, to NOAA, to the National Weather Service, to NASA, to NIH, and many, many more. There's been shootings at the CDC over vaccine misinformation, and the violence that's been happening historically in our schools is now happening more in our workplaces. We are not the first in history to experience what is happening, but the groups I've mentioned earlier are the first to begin living this modern nightmare. And the nightmare will eventually reach the American people at home and in the places like the Great Lakes region. It will negatively impact us all physically, mentally, emotionally, and certainly economically. As a new member of the EPA and a new AFGE steward, I can attest at the stark difference between my first year at EPA and my second year. Workers' rights are being eroded and our voices are being silenced. The almost 60 years of accumulated knowledge at EPA is exiting through the front door. EPA employees and other federal employees are sticking around because we care about our respected missions and the people we're doing it for. Please do your best now to continue defending our scientists, defending our federal services, and defending our environment. Hopefully next time we meet, we can again celebrate our achievements and celebrate Labor Day again. On the other side of these attacks on science. Thank you for your time, and I'm delighted to pass it off to my former regional administrator, Deborah Shore from EPA Region 5.
Thank you so much, Michael. Like he said, we would like to now welcome Deborah Shore. For nearly 15 years, Deborah Shore served as an elected commissioner on the board of the Metropolitan Water Reclamation District of Greater Chicago, the very large wastewater and stormwater utility serving Chicago and the 129 other municipalities in Cook County. In October 2021, President Biden appointed Deborah as regional administrator of the U.S. Environmental Protection Agency for Region 5 based in Chicago. Region 5 is comprised of 6 Great Lakes states and 37 tribal nations and hosts the Great Lakes National Program Office. Deborah served as regional administrator until January of this year. In addition, she served for a decade on the board of the Great Lakes Protection Fund. Deborah and her spouse frequently paddle their kayaks on the Galleon River out of New Buffalo, a tributary to Lake Michigan. She will be joining us today from their place just east of Michigan City, Indiana, about 1.5 miles south of the Lake Michigan shoreline. Everybody, please welcome Deborah. And let me see if I can get Deborah on the screen right now for everyone to see. Okay, let's see. 1 second. I'm just gonna, Okay, there we go. We're ready for you, Deborah.
Thank you, Jane, and I hope all of you will join me in thanking Mike and all of his colleagues in Region 5 and throughout the entire agency for their service. I can tell you honestly that serving as regional administrator was the best job I ever had, and it was because of Mike and his colleagues. They are such smart, devoted professionals who have a shared sense of mission. And throughout the federal civil service, these are people who only want to work to serve the American people. And what is happening in the current administration, the way they are being treated with willful cruelty and the dismissal of science and expertise is just heartbreaking. So Mike, know that we have your back. Please stand strong. We are going to do all we can from the outside to support you and your colleagues. In terms of the Great Lakes, what a wonderful global asset those of us who live near or have access to the lakes have. And thus we have I believe, both a statutory responsibility, but also a moral obligation to demonstrate wise stewardship, sound stewardship, and careful protection of these precious resources. It's a renewable resource, namely fresh water, but it's a finite resource. And the eyes of the nation and the world will be on us, looking to see whether we are wasteful or protective and careful stewards of the Great Lakes. For a long time, the Great Lakes National Program Office, what's known as one of the geographic programs of EPA, has been housed in Region 5. So not only 6 of the states, but also portions of New York and Pennsylvania are included in Region 5. And many years ago, the most contaminated areas around the Great Lakes, from industrial pollution and so forth, were called areas of concern. And they were identified as targets for cleaning up the Great Lakes because early planners knew that we couldn't have healthy ecosystems if they were contaminated with toxic sediments and chemicals and so on. And so that work has been underway for years. But in the Biden administration, through the infrastructure law, EPA was granted, Region 5 was granted $500 million, which it was decided would accelerate cleanup of these areas of concern. And so that work was underway from 2022 on, and the hope was that almost all of these contaminated sites, the largest management work would be completed by 2030. We don't know if we'll be able to keep that schedule, but a great deal of work is being done. And in places where the bulk of the cleanup has already occurred and they've been delisted, as it were, people are seeing enormous economic revitalization and access to the Great Lakes that people didn't previously have in Duluth, in Sheboygan, in Lorain, Ohio, and Rochester, New York. And so that's an important thing. In 2010, the Great Lakes Restoration Initiative was created by President Obama to focus congressional spending on cleanup and research and improving the ecological health of the Great Lakes. That funding has continued even in the first Trump administration. And the good news is that the budget of about $368 million for FY26 is holding, but there is showing a budget cut in federal year budget 27, which would be about a 20% cut. Happily, Congress has defended support for the Great Lakes Restoration Initiative in a bipartisan way, and we hope that will continue. However, due to other cuts in the current administration, the Great Lakes National Program Office is running about 12 people fewer than before. That's about a 20% cut in the number of folks who administer these programs. And another big concern are the proposed cuts to EPA's Office of Research and Development. Indeed, the sort of wholesale dismantling of that office and assigning scientists to different program areas. This will affect Region 5 because there are a number of labs that the Office of Research and Development has staffed, one in Duluth, one in Cincinnati, focusing on freshwater science. In addition, there are 2 research vessels that go out on all the Great Lakes every summer to take samples to study the health of the Great Lakes, the presence of invasive species, the presence of harmful algal blooms. One of those vessels is called the Lake Explorer, and it is part of the Office of Research and Development budget. And I don't know whether it will go out on the lake next summer because it's in poor shape. It may not pass its next inspection, and finding a new research vessel and paying for it is a big ask. The Lake Guardian is out of Region 5's budget, and it has continued to gather data, but they work in partnership. One is a near shore vessel, the Lake Explorer, the other a deeper water vessel. And there's 40 years of scientific data that's been gathered by these ships out on the Great Lakes that may be in jeopardy if the Lake Explorer can't continue its work. So those are the sorts of things that are looming, that are very concerning, and where your advocacy on behalf of EPA and its scientific endeavors is absolutely essential. Thank you, Stand Up for Science, Jane and all your colleagues, for what you're doing. I'm happy to linger and perhaps answer questions later on.
Thank you so much, Deborah. I think we have time. If anyone has any questions for Deborah, she can answer a few right now. Yes, absolutely. We have someone in the audience, Mike.
Hi, Deborah. You mentioned a number of cleanup sites. What are some of the chemicals or toxins that are being cleaned up there?
I don't know if you heard that, but the question was, you mentioned some chemical sites. What are some toxins that are being cleaned up currently?
I'm not the expert on this, but, and it depends on the site. For instance, along the Detroit River, there's a number of chemical companies and others that have released PFAS, chromium, some sites have PCBs from paper mills along the Kalamazoo River, for instance. And so they test the sediments to see what's in them and to determine the cleanup plan for various sites. In Waukegan Harbor, there's been asbestos from a former industrial site. In Grand Calumet Harbor, there's constituents of oil and other heavy metals. So it depends on what was there and the tests that they show.
Thank you so much, Deborah. Please a round of applause for Deborah. Thank you so much for being here today.
You're welcome.
Okay. And now we are going to start our kind of lecture talks, style talks. If my slides will come up. Okay, there we go. Does everyone online see this? Okay. Our next speaker, oops, control. One second, let me just share my slides one more time. Yeah, that's what I'm doing. Okay. Is that back for everyone online as well?
Yeah.
Thumbs up. Okay, great. Okay, thank you for bearing with us. I want to introduce our next speaker, Dr. Rachel Peretsky. Rachel Peretsky is a professor at the University of Illinois Chicago, where she studies various aspects of microbial ecology, diversity, community structure, and interactions in aquatic environments. She has done pioneering work looking at genes and gene expression of microbial communities in the open ocean, freshwater lakes and rivers, and wastewater. She is currently the scientific lead for the Chicago and Illinois current wastewater surveillance efforts, where she partners with the Discovery Partners Institute, Argonne National Library, Northwestern University, Rush University Medical Center, and the Chicago and Illinois Department of Public Health. Her work has been funded by a variety of agencies, including NSF, NIH, CDC, and NOAA. Everyone, please give a round of applause and a welcome to Dr. Rachel Peretsky. If you click next, your slides are.
Okay. Can I move?
Oh, yeah. Absolutely.
Perfect. Awesome. Okay, great.
You might
Oh,
need to-
I have to mouse.
That's
Sweet.
great.
All right. Well, I think I was gonna say it's great to be here, but the circumstances surrounding it are not awesome. But I'm happy to talk to you about a little bit about my work. I'm gonna keep an eye on time because I tend to ramble. But I think Deborah really set this up well. And I was gonna lecture style, but I'll make this a little bit interactive. So the theme of this was the health of Lake Michigan. But what do you think of when you think of a healthy lake? What is a healthy lake?
Someplace you can swim in.
Someplace you could swim in.
Diversity.
Has a lot of biodiversity. Great. Anything else?
Happy fish.
Happy fish. Sweet. So a lot of times you think of unhealthy water environments as being maybe contaminated. These two bottom pictures, I'm not sure if my mouse works. You see it? Oh, nope. Hold on. These two bottom pictures are actually from the Chicago River. You might see them if you walk around by the Chicago River, these signs that I always joke the MWRD, the Metropolitan Water Reclamation District, has these signs that says protecting our water environment, but it always looks like protecting us from our water environment, maybe. Maybe it's not that bad, but this is what we think of when we think of unclean water bodies. So we heard from Deborah, especially as she was answering that last question, what are some of the top threats to Lake Michigan? And when I think of, there's a lot, and the Great Lakes in general, but I think of things like shifting lake levels, the water, and water availability. Like Jane mentioned, it's a major source of drinking water. It's our source of drinking water. So this is important as the lake dynamics change. invasive species, which Deborah also mentioned. Especially, we have things like the mussels that have invaded the lake and really changed the ecosystem dynamics. Pollution, which Deborah kind of wrapped up on, talking about some of the contaminants that are introduced into Lake Michigan. And one of the areas where I'm interested in, and I do research on, is the aquatic food web. So somebody yelled out diversity or biodiversity of species, disruption of the aquatic food web. So here's an example of an aquatic food web. We have organisms that are get their energy from sunlight and kind of fuel the lake. These are bacteria, algae, small creatures that live in water systems, get their energy from light and kind of fuel fixed carbon from CO2 and into organic carbon, and kind of fuel the aquatic ecosystem and other organisms that live there. And then we have organisms, primarily bacteria, which is my main area of research. And these organisms use organic carbon, well, many carbon sources, but and some of the phytoplankton are bacteria too, but use organic carbon and break that down kind of the same way that we eat carbon, sugars and stuff. And so this is the whole, or this is a big element of the aquatic food web. Here's some mussels. So I'll tell you about how we sample in Lake Michigan, but this is from last summer aboard the Lake Guardian. Some of the areas of Lake Michigan are just carpeted with these invasive mussels, and this is one scoop of these organisms. And we're interested in the mussels partly as a component of this food web, but also as maybe sentinel species, because they're filter feeders and can bioaccumulate different contaminants and organisms and stuff. And so that's one element that we look at. But what's happened is, as these mussels have invaded the lake, they feed, so they're filter feeders, they feed on these phytoplankton, the tiny organisms that fix carbon and are fueled by the sun. And this whole area that's known as the microbial loop, it's like a food web, but it's the interaction of phytoplankton, viruses, bacteria, all sorts of other tiny organisms that are important for generating nutrients, cycling nutrients. And this is where a lot of my work in aquatic systems is based in. These organisms also play a role in things like cloud formation and, of course, fixing CO2 and photosynthesizing, but really connected to all life within the lake. And so as these mussels have proliferated, they've drawn down the phytoplankton. There used to be major phytoplankton blooms every spring and summer, and now these blooms don't happen. And certainly when they do, maybe in coastal environments, but they're not out in the middle of the lake in these large phytoplankton blooms. And so it's really shifted all the dynamics that happen. So I told you I'm interested in microbes. They're really abundant. Microbes, bacteria, archaea, viruses inhabit pretty much every environment that supports life. And I just like to kind of wow people. There's about 10 to the 30th on that order of microbial cells on Earth. So more microbial cells on Earth than there are stars in the universe. In fact, we're at least half of us is microbial. So this is some of the data that we've generated some years ago. In a drop of Lake Michigan water, there's over 1 million cells, bacterial cells. And this is from a paper we published some years ago, where we compared microbes offshore and nearshore. And all this is showing that there's a whole variety of phyla of bacteria, lots of different types of bacteria, and they're different between the nearshore and offshore environments. Deborah mentioned the EPA research vessels. We've taken advantage of these, participated. So since about 1981, I think it launched, the Lake Guardian has been going out doing these spring and summer surveys. And so if we lose this, we lose decades of monitoring. They do all sorts of characterizations of sediments, water, air, and scientists. It's a full research vessel, chemistry and biology labs on board, sleeping accommodations. And folks from my group, we've gone out a bunch of times. But these are some folks from my group who were out last summer, not this past summer, but they sampled. So the Lake Guardian samples all of the Great Lakes, and then each year another Great Lake gets more intensive sampling. So it changes which lake is the lake of the year. And so this is some folks from my lab. In the lab on the boat, water samples are collected in these Niskin bottles that get sent overboard. Same type of way we sample in the ocean. It goes in, the bottles close at different depths. You bring it up and you can do all sorts of research on those water samples. There's also, I showed you how we collected mussels, there's sediment cores, there's all sorts of stuff on board. So I just wanted to also share that this is all like the work that we have done or types of things that we're thinking about in terms of the health of the lake. But the lake also impacts our health. So we know this because we drink the water from there. But there's also all sorts of aspects of the lake that can influence our health. And so these are so each of these M samples are samples that we collected in Lake Michigan some years ago. And we looked at for the presence of genes that confer antimicrobial resistance. So this is a whole big threat to our health, the proliferation of antimicrobial resistance. And these are all sites that we've kind of followed from a wastewater treatment plant where there's hundreds of wastewater treatment plants that discharge into Lake Michigan. Chicago doesn't. We discharge into the river, which has reversed its flow, so it flows downstream, not into Lake Michigan. But there's about 100 other municipalities that do discharge into Lake Michigan, and so we estimated about 10 to the 9th resistance gene carrying organisms that are released through wastewater treatment plants into Lake Michigan every day. This just shows a variety of different antimicrobial resistance genes we see. Deborah also mentioned chemicals, PFAS, which has gotten a lot of news. So just before the Trump administration, there was a new legislation about regulating PFAS, mostly in drinking water. And I don't know if that's fully been reversed, but there's been talk about reversing it. But PFAS is definitely of concern. It tends to bioaccumulate and biomagnify in life in the lake. This is some work I've done with a relatively new professor at Loyola. On the right-hand side is concentration. So some of those samples that we collected aboard the Lake Guardian last summer, looking at PFAS concentrations in the lake. Urban environments are hotspots for delivery of PFAS. So it doesn't just come from industrial processes, but it's deposited by through air as well. And so definitely managing and understanding PFAS and its sources and fates is really important. And we need to understand the dynamics better to be able to manage that. Another aspect of lake health or related to our health is the beaches. In Chicago, we love our beaches, swim in it all summer. Abhilasha Sharista, who's a professor in the School of Public Health at UIC, has been working for several years monitoring the quality of water at the beaches and determining whether it's safe for us to swim in it or not. And so I want to show this. How am I on time?
Our beaches are overall very clean, but also very safe because of the testing.
Back in 2012, the US EPA came out with this rapid qPCR method where states could use this method to inform the public the same day about the water quality. We test for enterococci DNA. The US EPA has a certain threshold. If it's above that threshold, caution is advised for swimming.
A water sampling technician collects water samples from 18 beaches for the Chicago Park District. We also have samplers who are collecting water at Evanston beaches and Winnetka beaches. They begin at sunrise at approximately 5:30 a.m. and deliver the samples here at the School of Public Health West at 8 a.m. We collect 2 water samples, one from one end of the beach, one from the other end of the beach, and we use those to mix them together and develop a composite image of the bacteria in a given beach. We also use a 100 milliliter bottle. We open it to the air, we hold it for about 20 to 30 seconds, and that's how we know that the bacteria in the beach water samples are not from the atmosphere. Once the qPCR process is completed, myself or Abhilasha then cleans the data and sends it to the park district in order to determine whether or not the water is safe to swim in.
This was a good opportunity to learn more about all these different types of public health fields and then build connections with people. One of the main things that I'm very proud of about this role is being able to be connected in the Chicago community. A lot of times people will come up to me while I'm sampling at the beaches and asking me questions about what we're doing. People are really open to learning about the science, and they're grateful that the parks and UIC are out there doing some good work to help keep people safe.
Our beaches are.
All right. So just to wrap it up, I promise I'm finishing up. So who pays for all this research? It's really you. It's the general public that pays for the research that we do in the university. These are some federal agencies that we tend to receive funding from, not an exhaustive list. A lot of Great Lakes work was historically funded by the National Science Foundation under their biological oceanography program because it's such a big body of water. It falls under the BioOcean Directorate. What we do is we write proposals, which often take like a year, many months to put together. It depends on the deadline. Sometimes we work quickly, but we work together, put together a proposal. It takes university resources, admin staff to help develop these proposals. They then get critically reviewed by our peers, by program officers. The success rates can vary a lot, but they're typically low. So 8 to 30% actually get funded. But there's all sorts of strict rules that you have to adhere to once you get the funding. And now it's even more bananas. I don't know how much people know about this, but I currently have funding from the National Institutes of Health, for example, and Jane mentioned the words that we can't say. And so there is a list of words, and they tell us you cannot, this is unrelated, but it's infectious disease research, and they say you can't say pandemic, you can't say vaccine, you can't say women, you definitely cannot say diversity. And so there's a list of words, and they will either cut your funding if you have it anywhere, or they will tell you to remove it, and they are enforcing these. So this is a really tough environment to research in, but it's important to convey that this federally funded work serves the public good. It's done by the people, for the people, and it's only about 3.5% of the US GDP. So it's not a lot of money from the US that's going to this, but it's so important to sustain this research. There was a lot of talk about indirect costs some months ago, and this is still an ongoing conversation. The federal government wants to cut indirect costs. This is a percentage of your grant that covers like admin and building, and it's not like a slush fund that goes to the university. It helps support following all those, maintaining all those guidelines and filing paperwork, keeping you accountable, facilities so that universities and other research institutions can carry out this work. And I'll just end with this. This is a great interactive piece that was in the New York Times some months ago, showing how the landscape of federal funding has changed since the Trump administration. So on the left is the 10-year average of about $2.5 billion or $2 billion. This is National Science Foundation only. I told you there's lots of federal grants, but this year it's down to proposed to be down to $989 million. And just this is in biology alone, this is a cut of about half the budget that had existed. So it's kind of grim. I think we're going to end, so I'll leave this for the end. With what we can do. There's QR codes here too. Stand Up for Science is a fantastic organization. Union of Concerned Scientists also has a lot of resources for what you can do as scientists, non-scientists to help advocate for science. A colleague of mine has a Substack, which has some great pieces.
Yes, I'm going to talk a little bit different things than Rachel did. We do work together, so there's an intersection, water and microbiology. I work mainly on water and talk mainly about kind of Chicago in the context of the Great Lakes. And the first thing I would say, Chicago is a coastal city. People don't necessarily think of it. They think of it as a Great Lakes city, but we're actually a coastal city and a unique one because Chicago here is located at the connection of the Great Lakes, the largest body of freshwater surface water in the world, and the Mississippi River system, which is the largest river system in North America. That's why Chicago is here. And it means that we connect to these two big water systems. We draw on both in different ways, and we impact both. In terms of threats to the Great Lakes, there have been a set of reports on this, and this one is from climate change report, and there were 5 areas that were highlighted in terms of potential climate impacts on the Great Lakes. Climate change in terms of temperature, water levels, public and economic impacts, so that includes health and jobs, of course. The lake ecology, that's what Rachel discussed, and some of the tributary watershed changes. So things that happen inland but propagate to the Great Lakes. And I've added to this some of the impacts on Great Lakes cities like Chicago. So this is a broader set of issues, some of which are local within cities, weather becoming more extreme, storms are becoming more extreme, leading to flooding, leading to heat waves, ongoing contamination and remobilizing old contaminants, some of the ones that Deborah Shore discussed, for example, introducing more pathogens and algal blooms, and also impacting some of our economy. So shipping is still a huge part of the economy of Chicago, and some of the changes in Great Lakes water levels impact the ability of boats. So that has direct economic impact, and I'll follow up on that later. All right, in terms of federal programs that benefit us, the residents and the Great Lakes themselves, there are a number. They're across many agencies. So this is one major example, the Great Lakes Observing System, which is a program that's really kind of managed by NOAA in partnership with Environment Canada. So this is providing information that everyone can use. It's directed at the federal governments, at municipal governments. It's available for the public and industry, and really aiming to improve the knowledge base and resources for the Great Lakes. There's a nice data viewer. Hopefully this is playing. Not playing. Is it playing? Okay. So I downloaded this clip yesterday. So this is the Seagull data viewer, and it shows air and water currents across the Great Lakes. So real-time visualization you can access anytime. I want to point out one thing. So this big yellow circle here, that's a circulation that's generally there in Southern Lake Michigan. So that actually carries all the contaminants from Chicago and deposits them offshore. So that's loaded with PCBs, dioxins, metals, arsenic. Basically, all the contamination of the last 150 years ends up there, and undoubtedly accumulating a lot of PFAS now as well. Locally, we have, of course, major flooding challenges. And I want to highlight here that dealing with stormwater flooding in Chicago is complicated. Being this Great Lakes coastal city on the coastal plain, it was very flat, famously built in a swamp, makes it inherently challenging to prevent flooding here. And there are many layers of infrastructure that are designed to capture stormwater and prevent flooding. So that's the ground surface. and multiple levels of subsurface infrastructure that are designed to carry away water and prevent surface flooding. This goes back to the beginning of Chicago as a city. So this is this 100 years ago view of the Chicago inland waterways. Chicago built here right at the Chicago River connection with the Great Lakes. And even going back more than 100 years, you have these connections made for shipping and to manage water between the inland waterways and the Great Lakes. This, of course, has been built up very extensively over the last 150 years. So this is a modern map with the controls we have on the inland waterways. Completely engineered system, not only to carry our wastewater away from the city, but also to support shipping, water exchange, and flushing of water through the Chicago River system. We've had major infrastructure investments here. So if we're talking about federal programs that are designed to protect health and support the economy of the area. One is the Chicago Tunnel and Reservoir Plan, or the TARP system, with these massive tunnels and reservoirs that are designed to store stormwater and keep it, especially from having sewer overflows to Lake Michigan and to the inland waterways. So this is more than a 40-year investment, mixture of local, state, and federal funding for both Great Lakes protection to keep contamination going out to the lake and to protect us and infrastructure in the city. And this has worked in general in terms of preventing these combined sewer overflows to the lake. Now, this is data I downloaded from Metropolitan Water Reclamation District. It shows the last 40 years. You see there were these really big discharges of raw sewage to the lake. Those have gone down quite a bit. I would say this graphic doesn't even fully capture it. It's really prevented all the small ones, nearly prevented all releases of water, of wastewater to Lake Michigan, and greatly reduced the inland contamination as well. It's also greatly improved the beach water quality. There used to be huge problems 15 years ago that beaches were often closed because of E. coli contamination. And now it's much better, as the video showed. All right, so additional challenges. We talk about the future of the Great Lakes. Rachel mentioned there's changing water levels. Naturally, they're changing water levels in Lake Michigan. So sometimes people get very worried, but it's sort of natural fluctuation in water levels. But this is expected to get more extreme. And one of the implications, we can expect more flooding at higher water levels, and we can also expect more erosion. So that is in the city, a couple of photos on the south side and then the north side with infrastructure damage, people living near the lake, and also a lot of beach closures. This is important both in terms of impact, especially in cities, but this also can serve to remobilize old contaminants. There are a lot of old power plants, factories, and other waste sites around the lake, so those can become flooded and remobilize old contaminants and make them new problems again. I'm going to talk now about some of the work that we and others, or we generally in the region, are doing to address some of these issues. The first one is the Crocus Urban Integrated Field Lab that Jane mentioned. So this is a big regional initiative led by Argonne National Lab, funded by the U.S. Department of Energy. It has two purposes. One is to just better understand weather interactions, water interactions within cities. Not well understood, actually, still, because cities are so complex and artificial. We can build anything in Chicago, really. And then secondly, to use that information to address some of the challenges like flooding. And I'll hone in on that a little bit. We have a few challenges. So not only is it flat and coastal here, but also we get these storms that sweep through that have really intense precipitation. So on the left there, that's just an image, a radar image of precipitation. And you see these bands of really intense precipitation. So something like an average value across the city doesn't do you that much good. You all probably kind of know this because you can see these storms coming, and it may not be raining where you are, but you can see the storm dumping water at the next neighborhood. So that presents a particular challenge that causes a lot of local flooding. We do have all this infrastructure. So the middle image is a map of the Racine Avenue pumping station sewer shed. That's all the sewer connections in the subsurface. Here, these are massive, and they're really the core infrastructure to take water from city streets, deliver it to the deeper parts of the system, and then out through the Chicago River. That is all generally old and very expensive. So we're looking for new solutions that could help reduce impacts, especially in neighborhoods. So there's a lot of interest in green infrastructure and tree planting in the use of green space for this problem. So in order to make that work, we really need to understand better what controls local flooding and how that interacts with the land surface and the green space. So this is a major focus of Crocus. And over the last 3 years, we built up this network of sites across the city, measuring atmospheric conditions, ground surface conditions, subsurface conditions, trying to track water from the atmosphere, understand how it propagates through the soil and the effects of plants and trees on that, and how that impacts flooding. So as of today, this is probably the best data collection for this atmosphere, land surface, subsurface, water in cities anywhere in the world. So it's been a huge investment, a huge amount of effort and successful. But unfortunately, it looks like it probably will not continue, right? I'm going to show you examples so you can see the value of this. These are just some photos of some of these deployments of the atmospheric sensors tied into distributed sensors in trees to measure sap flow and into the soil environment. So that's in a prairie at Chicago State University and some of the things we have at Northwestern campus. But a big part of this is to work within neighborhoods in the city. And this is an example from Woodlawn. So this is a green corridor vision from Blacks and Green, a kind of a community plan for the Woodlawn area to make this connected set of green spaces. This has been really interesting to buy up properties or to have them donated by the city, connect them up. So there's a real corridor of green space in a highly developed part of Chicago. It doesn't exist today. So we have worked with Blacks and Green to instrument this, collect rainfall data, and also monitor a number of these sites. So this will give us information to understand the role of vacant lands in storing stormwater. So not zero value in vacant lands, but sort of low. And then these are being either renaturalized or planted with food crops. So we'll understand the effects of that in reducing flooding. All right, so hopefully you get a sense kind of regionally, science-based, these kind of programs help us understand better interactions between weather and cities, but also directly usable by local neighborhoods and communities to solve local challenges. Unfortunately, this urban integrated field laboratory program is likely going to end. For Crocus in Chicago, funding to Argonne, which is the lead, will definitely end at the end of this year. Fortunately, the university efforts were funded separately, so some of them will continue for another year. But the data products that we've developed that are being used by local governments and communities, those will not continue. So this is kind of a major impact just in stopping data collection. Part of the broader efforts of the Trump administration, just generally decreasing data collection around weather and climate. Some of the federal programs, they've been restored by Congress, so they're strong supporting Congress for maintaining continuity of information, but not all the programs will continue. All right, lastly, I want to talk about something a little bit more optimistic, which is the Great Lakes Renew Regional Innovation Engine. This is led by Elena Harkness at Current. You can see her photo down there. So the key principle of this is that, we've always looked at wastewater as waste and tried to get rid of it. But if you think of what you can do with it, reuse the water, look at it as a feedstock, recover nutrients and make chemicals from it, then it becomes valuable. And since Chicago has some of the largest wastewater treatment plants in the world, if we view those as opportunities, we have a big opportunity. And this is the main focus of Great Lakes Renew. The other thing that Current has done a nice job of establishing is the value of water to the economy of Great Lakes states. So Illinois in particular. We all know that the water is valuable, but quantifying that in a way that politicians and other decision makers can use is a little bit challenging. So Current has studied this extensively and showed that water, or the water industry or water related industry in Illinois, produces about $17 billion per year. So that includes companies that produce water technology. We have a number of them in the area. It includes consulting companies and engineering firms that we have a lot in the area that work on water, and includes shipping, which is still very valuable, now going through Calumet around Chicago, but still very valuable in the state, and water intensive industries. So we have a lot of high tech industry in terms of manufacturing, chemical industry, pharmaceuticals, biotech. All of those industries need a lot of water and are here in part because of the water. So really valuable and contributing to about 1.5 million jobs in Illinois. Current's vision is to take that and make it circular. That means instead of using everything once, getting rid of it and putting it down the Chicago River to the Mississippi, to the Gulf of Mexico, to extract value from that. So this is the circular economy that you can recover not only the water, but also fertilizers, chemical products, critical minerals, and then can drive further economic development. Now, that's kind of the key principle of Great Lakes Renew. This is some of the largest funding from the National Science Foundation ever, scheduled to be $160 million over 10 years. We are just completing year 2. So now we have some of these same questions. I mean, I would say this program, and there are dozens of these across, touching, I would say, practically all 50 US states, providing real economic value. They were funded under the CHIPS Act, most of them. And so there's kind of a question just in this sort of destruction of programs that were initiated under prior administrations, whether this will continue. So far it looks good. We're spinning up these efforts, really building up the research and the partnerships, try to turn them into technologies that will create more jobs and be valuable for the region. But there is this uncertainty whether any of these programs will continue. I think I will end there in the interest of time, hopefully get a sense that there are kind of inherent hazards here in the Great Lakes region. We need infrastructure to protect us from that. And this is a big role of federal funding. So not only flooding, but also to remove lead, to protect our drinking water quality, just in general. And also there are these emerging opportunities. Federal funding drives economic development, it drives technology. It has produced everything you see in the room, basically, as well as computers, AI, the internet, like all our kind of our modern kind of technological innovation depends on research funding. So it's really important that this continues so that we can have further progress and benefit really all of us.